The next topic is material substitution. This is a great choice whether you're trying to lower the cost or reduce the toxicity. Let's say you have a current design that's doing really well. Even if the current choice of material is okay, there's no problem, we should still always explore the opportunity for material substitution. We can set aside the old adage, if it ain't broken, don't try to fix it. In this case, that doesn't apply. When you substitute and do so properly, it presents an opportunity to lower the cost or improve the design. So you should constantly, periodically, every year or every second year, look into the choice of materials that seem to work and ask yourself, do we have something else that can do the job? However, you just cannot substitute a material because it's cheaper or more abundantly available. The bigger question is, can it do the job? The functionality is important, so we have to bear that in mind. Oftentimes, substitution opportunities arise because new extraction methods have come up, or there have been some new approach to processing which can use a different kind of material. So technology changes. And so even though 2 years ago you didn't have a choice, 2 years later you may have a choice. So you must periodically revisit this option of material substitution. The next thing is some recommendation on how you select material, right? Oftentimes when you look at a design, we are fixated on one or two properties and exclusively focus on it. That's not the best way to go. For most design situations, you will have multiple properties. It's not just, say, the thermal conductivity or the mechanical strength. Durability may be a consideration, recyclability may be a consideration, the ability to form the material into different shapes, manufacturability may be a consideration, environmental impact may be a consideration. So there's a whole host of things. So the best thing is to look at material selection from a multi-parameter selection standpoint and not get fixated on one or more. So what are some of these parameters we might look at? You know, we might look at the absolute abundance of the material. You know, is it available by itself, or does it appear as a hitchhiker material? And then we also look at how energy intensive it is to mine and process this. What kind of environmental toxicity does this material pose? You know, is it possible to recycle it? So there's a whole range of things we must look at. And so, you know, given that the physical and chemical properties are alike and the cost is reasonable, then you know, we should choose a product that is optimal in a very broad sense and not confine ourselves to a few properties. There is a chart in your book that may be useful for our discussion here. This is a material selection chart, and it looks like so, right? So on the leftmost column you have various elements like lithium and beryllium and carbon and nitrogen and so forth. Here are the various parameters. So you're looking at abundance, we're looking at whether it's available on its own, that's what abundance means, or is it a hitchhiker. Then you're looking at geography. What does that mean? It means, is it available in many places? Is it spatially evenly distributed? Or is it just focused in all of North America? The only place it's available is in northern Colorado. Or is it available in Alabama and California and so forth? Energy. Is it very energy intense or it's not? And the toxicity. So we have a scoring system, we give points, and then we have an overall score, which is the sum of the partial scores. And then we have a use rating, which, you know, you have N, H, and M. So let's look at what these numbers mean, right? So here's a legend on what it means. So on the abundance, if you have a score of 3, that means it's very abundant, which is a good thing. A score of 0 means it's very scarce. So 3, 2, 1, 0, 3 being better. On the hitchhiker, a score of 2 means it is not a hitchhiker, which is a good thing. and a score of 0 means it's totally available only as a hitchhiker. On geographic availability, score of 3 means there are it's widely available. Score of 2, sorry, and 0 means it's confined to just maybe one continent. The energy score of 2 means it has very low process energy requirement. Score of 0 means very high energy requirement. So as you can see, the last one here is toxicity. This is the only score where the higher number is undesirable. A toxicity score of 2 means very high toxicity. Score of 0 means low toxicity. So on the last, which is the recommendation, use rating, no means no supply limitation, M means moderate supply limitation, H means high supply limitation. So let's go back to the table and look at silver, which is number 47, right? So you see various scores. It's got an overall score of 8. So there are moderate supply limitations. It's got a score of 8. So you can use the overall score as an indication of whether that particular material from a multi-parameter standpoint is appropriate to use, or should you go back and look for other materials. Now your chapter has just 3 pages, but you have available in the form of CDs and so forth, material databases that can give you a much more comprehensive list.